Imagine for just a second that the very foundation of everything around you right now, the electricity lighting up your room, the power keeping your phone alive, the fuel that brings food to your local grocery store, just suddenly hits a wall. What happens when the actual backbone of modern life simply runs out of fuel? Or honestly, what if that fuel is quietly making the planet uninhabitable while we sleep? We are standing right at the edge of a massive impending crisis. But at the exact same time, we're on the brink of the absolute greatest technological shift of our generation. Welcome to The Explainer. I am so thrilled you're here today because we have got a seriously fascinating journey ahead of us. Today, we are completely unpacking the energy revolution, the future of clean power and a net zero world. We are going to break down exactly how the globe is going to shift away from fossil fuels, adopt clean energy, and actually make a net zero world a reality. I absolutely love diving into massive topics like this, because once you see the underlying structure, all that chaos you see in the daily news cycle suddenly makes perfect sense. Okay, let's dive into our roadmap for today. We'll start off with the fossil fuel crisis. Then we'll explore the clean energy arsenal that's stepping up to save the day. From there, we'll tackle storage and smart grids, zoom out to look at the global energy transition model, and finally, uncover what all of this means for your wallet with future business and investment. Let's get right into it with Section 1, the fossil fuel crisis. Our world basically runs on limited and, frankly, dangerous fuels. And the chain reaction here is just undeniable. Our massive fossil fuel use directly leads to widespread CO2 emissions. Those emissions go up, they trap heat, and that causes global warming, which is currently accelerating into a full-blown climate crisis. So the undeniable conclusion here is simply the absolute need for change. The system we have right now is entirely unsustainable. It's really vital to recognize the fatal flaws of our current heavy hitters. Take coal, for instance. It gives us massive power, sure, but the cost is incredibly high pollution. Then you have oil. Oil literally built the modern industrial world, but it is a strictly limited resource. One day, it will run out. And then there's natural gas, which gets touted as a bridge fuel a lot, but it still fundamentally releases greenhouse gases. This completely cements why the status quo just cannot last. When you stack these two paradigms side by side, the necessity of shifting gears becomes incredibly obvious. With fossil fuels, you're looking at high pollution, limited availability, and inevitably, increasing costs as they get harder and harder to dig out of the ground. But with renewables, you get low pollution, unlimited availability, because, the wind and sun aren't going anywhere anytime soon, and, crucially, exponentially decreasing costs. To give you some perspective, solar power costs have dropped by nearly 90% in just over a decade. The economics are shifting exactly as fast as our environmental needs. So what do we replace it with? Section 2, the clean energy arsenal. First up, we have solar energy, which a lot of folks consider the future king of power. The advantages are absolutely stellar. It's clean, it's globally abundant, and it offers incredibly low-cost energy in the long term. A brilliant real-world example of this is happening in India right now, where they are building massive, dedicated solar parks stretching across whole deserts to completely redefine energy scale. But the limitations are real too. You have high initial setup costs, and of course, night dependency. When the sun sets, the power production literally stops. Next up is wind energy. Modern wind turbines are absolute marvels of engineering. Seriously, some of these things are taller than skyscrapers, and they ingeniously convert air movement directly into electricity. It's remarkably clean and highly scalable, but it is heavily location dependent. You need consistent, really strong winds, which means you usually have to build offshore or on vast open plains. Plus, there are noise issues that prevent you from putting these turbines too close to where people actually live. Then there's nuclear. This is our heavy lifter. The massive energy output and incredible stability provide a constant, reliable baseline of power with virtually zero CO2 emissions. But, as we all know, the trade-off is pretty steep. We have to manage serious safety concerns and the incredibly complex, centuries-long problem of radioactive waste disposal. And finally, we have the technology that so many experts are pitching as the absolute next big thing in fuel: hydrogen, specifically green hydrogen. Let's break down this highly technical concept step by step, because it's pretty wild. You literally start with just water. Then you apply a process called electrolysis, powered by renewable energy, to split that water. This isolates the hydrogen gas, which you can then burn or use in fuel cells for pure energy. And the only byproduct? Water vapor. It's this perfect, clean loop that could literally one day power the massive cargo ships bringing packages to your door. But we have to address the elephant in the room. Section 3, storage and smart grids. Here's the thing. Since the sun isn't always shining and the wind isn't always blowing, all that perfectly clean energy needs a place to live until we actually need to turn on the lights. And our energy storage solutions are evolving rapidly to handle this. We rely really heavily on advanced battery technologies for quick, short-term storage. But for massive, grid-scale storage, we use something called pumped hydro. We literally use excess power to pump water up a huge hill and then just let it flow back down through turbines when we need the juice. And, as we just touched on, we can also use that excess power to create hydrogen for long-term storage. And that brings us to the ultimate fix, the smart grid. Instead of a dumb system just pushing power blindly, energy moves from the source to a network that acts like a giant, intelligent nervous system, actively managed by AI. This AI is constantly crunching data to predict exactly when and where power is needed, ensuring that literally not a single watt is wasted. It perfectly balances the solar, the wind, and the storage, completely in real time. So how do we actually pull this off globally? Section 4, the energy transition model. Look, this massive physical shift isn't going to just happen overnight. It's a monumental logistical puzzle. But we do have a structured, phased framework. Phase 1 is the aggressive reduction of the most polluting legacy fuels, like coal. Phase 2 happens simultaneously. It's a massive global sprint to build out our renewable capacity. And that leads us perfectly into Phase 3, the full takeover, where renewables power the world entirely and we leave fossil fuels in the past. When you bring this entire master framework together, you see one continuous step-by-step cycle that builds toward a totally sustainable future. We start at the legacy system of fossil fuels, shift our generation over to renewables, solve the intermittency gaps with storage, intelligently manage the whole shebang through the smart grid, and ultimately arrive at our grand destination, a net zero world, where our carbon emissions are entirely balanced out. Which brings us to the final piece of the puzzle. Section 5, Future Business and Investment. Make no mistake, the energy transition is practically powering modern economic growth. In the solar sector, physical installation and maintenance is a booming, multi-billion-dollar industry right now. With electric vehicles, the real gold rush isn't just selling the cars, it's building out the charging infrastructure needed on literally every street corner. And with hydrogen, early investments in what will absolutely be the future fuel for heavy industry and global shipping could yield massive returns. When we project into that crucial window between 2030 and 2050, the data points to a really spectacular payoff. We are going to witness the irreversible decline of fossil fuels, the total dominance of renewable generation, and the rise of brilliant, silent, smart cities powered entirely by clean energy. The technology and the policy are finally aligning for an incredible success story. But honestly, understanding the mechanics is only half the battle. We know the current system is unsustainable. We have the clean energy arsenal, we have the storage solutions, the AI grids, and the economic incentives all completely mapped out. The master blueprint is sitting right in front of us. So I'm going to leave you with this provocative final thought. We have all the tools, but do we have the societal will to implement this technology and policy fast enough to actually meet those 2030 to 2050 predictions? It's a transition that requires every single one of us to engage. Thank you so much for joining me to explore this incredible topic today, and keep learning.